Hello everyone, this is Dr. A. Muma Maheshwari from Department of Mathematics. Today I am going to deal a topic called Propositional Logic from Discrete Mathematics. We all know that Discrete Mathematics is a field of mathematics which deals with logics and proofs. So let us now learn what propositional logic is. First of all, we have to know what is a proposition. A proposition is a declarative sentence that is either true or false but not both. We can use certain letters to denote the propositional variables such as P, Q, R, etc. The truth value of the proposition is denoted by T. If the true proposition, if it is false, then it is denoted by F. Now let us give us some examples for propositions. The given sentences are declarative sentences and thus we call it as proposition. Let us see the first example. Toronto is a capital of Canada. It is a declarative sentence and it is true. We call this as a proposition. Example 2 states that 1 plus 1 is equal to 2. It is a proposition and it declares some true value. Similarly, you can state the example 3, x plus 1 equal to 2. We will be giving certain values for x so that the values will differ. Proposition 2 is true whereas 1 is false, and sentence 3 is not a proposition because they are neither true nor false. Now let us see the examples for propositions. Here certain sentences are given which are declarative sentences. Toronto is a capital of Canada, which is not a true statement. 1 plus 1 equal to 2, it is a true statement. X plus 1 equal to 2 is not a proposition at all because it is neither true nor false. Here proposition 1 is false and 2 is true as per the logic. Consider these propositions. What time it is? Second example is given as read this carefully. These sentences are not propositions because they did not declare any statement. They did not declare any values, whether it is true or false. So that these statements are not propositions. We have to know what is the logic behind the proposition. We call it as propositional logic. It is an area that deals with propositions. We also call it as propositional calculus. Many mathematical statements are constructed by combining one or more propositions. We can introduce new propositions which are called as compound propositions by combining the existing propositions by using the logical operators which are nothing but the connectives. Here we are declaring certain operators which are called as logic operators. Negation. The negation of a proposition P is denoted by not P. It is a statement given by it is not the case that P. We can use this example to denote the negation. The negation of the proposition, here a statement is given, Michael's PC runs Linux, is it is not the case that Michael's PC runs Linux. So negation is nothing but just the opposite form of the given statement. It is not the case that P. Then this negation can also be simply expressed as Michael's PC does not run Linux. There is another logic operator called conjunction. The conjunction of propositions P and Q denoted by P and Q is a proposition P and Q, which is denoted by the symbol P and Q. The conjunction P and Q is true when both P and Q are true and it is false otherwise. The truth table of the conjunction is given by when two values P and Q are true, then the truth value of P conjunction Q, that is P and Q, is true. When either one value of the propositions, the two propositions are false, then the truth value of P and Q will be false. The truth value of P and Q will be true only if both the propositions P and Q are true. In either case, it is false. Thus, we came to know about conjunction. Let us see one example for conjunction. The conjunction of the propositions P and Q, where P is a proposition Rebecca's PC has more than 16 GB free hard disk space. This is one sentence, one statement. And Q is given as a proposition the processor in Rebecca's PC runs faster than 1 gigabytes. So what is a conjunction of these two propositions P and Q? That is, Rebecca's PC has more than 16 GB free hard disk space and the processor in Rebecca's PC runs faster than 1 gigahertz. This conjunction can be expressed more simply as Rebecca's PC has more than 16 GB free hard disk space and its processor runs faster than 1 gigahertz. Thus, the conjunction of two propositions P and Q is nothing but we are expressing two propositions by a conjunction called AND. Now let us learn the concept of disjunction. What is disjunction? The disjunction of the propositions P and Q denoted by P and Q. It is given by the symbol P and Q. Now let us learn the topic of disjunction. The disjunction of the propositions P and Q, which is denoted by P or Q, is nothing but the proposition P or Q given by the symbol P or Q. The truth value of P or Q is false when both P and Q are false. In other case, it is true. That is, when the two propositions P and Q are false, then the disjunction of the two propositions will be having the truth value false. In other case, the truth value will be true. That is, either any one of the truth values, any one of the statements P and Q can be either true or both true. In this case, we say that the disjunction, the OR values, the truth table values, truth values of P or Q is nothing but true when both are true, true when either P or Q is true, and false if both the statements are false. Here is an example of disjunction. The disjunction of the propositions P and Q, where P is a proposition Rebecca's PC has more than 16 GB free hard disk space and Q is a proposition that the processor in Rebecca's PC runs faster than 1 gigahertz. Is now we are going to include the disjunction connective. Rebecca's PC has at least 16 GB free hard disk space, or is the connective we use here, or the processor in Rebecca's PC runs faster than 1 gigahertz. And this is a perfect example for disjunction. Now let us learn what is exclusive OR. The exclusive OR of the propositions P and Q is denoted by P exclusive OR of Q. P or Q. The conjunction P or Q is false. Now let us learn the concept of conditional statements. Let P and Q be propositions. The conditional statement P implies Q is a proposition of if P then Q. The conditional statement P implies Q is nothing but it is a proposition if P then Q. The conditional statement P implies Q is false when P is true and Q is false, and true otherwise. In the conditional statement P implies Q, P is called the hypothesis and Q is called the conclusion. And let us now check the truth values of P implies Q. That is a conditional statement. If the truth values of both the statements are true, then the truth value of the conditional statement P implies Q is also true. When the truth value of the first statement P is true and Q is false, then the truth value of P implies Q will be false. If the truth value of P is false and the truth value of Q is true, then the truth value of P implies Q is true. If both the truth values are false, then the conditional statement has a truth value true. Now let us learn the concepts of converse, contrapositive and inverse. The proposition Q implies P is called the converse of the proposition P implies Q. The contrapositive of P implies Q is a proposition given by Q implies not P. The proposition not P implies not Q is the inverse of the proposition P implies Q. Here, we should note that the contrapositive always has the same truth value as P implies Q. Here is an example for the conditional statement given by the home team wins whenever it is raining. Here, the contrapositive of this conditional statement is if the home team does not win, then it is not raining. The converse is if the home team wins, then it is raining. The inverse is given by if it is not raining, then the home team does not win. Now let us learn the concepts of biconditionals. What are biconditional statements? Let P and Q be propositions. The biconditional statement P if and only if Q is a proposition P if and only if Q. The biconditional statement P if and only if Q is true when P and Q have the same truth values and it is false otherwise. The biconditional statements are also called as bi-implications. Now let us check the truth values for the biconditional statements. When the truth values of P and Q are true, then the truth value of the biconditional statement P if and only if Q is also true. If the truth value of the propositions P and Q are false, then the truth value of the biconditional statement P if and only if Q is true. That is, when both the truth values are same for the two propositions, then the truth value of the biconditional statements are true. In other case, they are false. Let us check the example for biconditional statement. The biconditional statement of the propositions P and Q, where P is a statement given by you can take the flight and Q is a statement given by you buy a ticket. That is, how to say this as a biconditional statement? You can take the flight if and only if you buy a ticket. Thank you all.